Okay, good afternoon class. As you can see, at this point you guys have completed this paper where you had to do it for homework, okay? So this is a control test 1 of last year. Okay. So as you can see, there were sections that was done with this class that you guys didn't do, okay? However, I need to answer it anyway for the purpose of the video, okay? Otherwise I must find a group where I can do it with. I'll just indicate what you haven't done as yet, okay? So at this point it was for 2 hours, 100 marks, okay? Which means to say we are behind. Okay, I'm moving a bit slower with you guys. Not because you are slower. I thought you would have benefited more, but it doesn't look like you guys made full use of it. But anyway, let's go. So this question should we have been able to answer. We are told that sine of A is equal to 3 over 5, where A is greater than 90 but less than 270. What does that mean? Firstly, sine is positive. Which quadrant is sine positive? Quadrant 1 and 2. Then we are told that A is greater than 90 but less than 270. Let's put your quadrant 2 and 3. So which quadrant do you think we're going to draw it in?
Immediately make a user to the office immediately. Thank you.
Okay, so that is your A angle there. What does sine stand for? Opposite over hypotenuse. So opposite is 3, hypotenuse is 5. If I apply Pythagoras, I'm going to get 4 and minus 4. Not so. Which one of the two is it? The negative 4. Okay. Determined by means of a sketch. There's the sketch. Without the use of a calculator, the value of. So going with this here. So if you look at the diagram, what do you notice? I do not have double A. Well, I don't have 2A. However, I got angle A. So what do is, I change that to 2 sine A cos A over cos squared A. Are you all okay with that? And then from there, you see that's one step, grade 12 work, the rest is grade 11. Okay, so I got 2 sine stand for opposite, which is 3 over 5, cos is adjacent of hypotenuse, over cos, it's adjacent over hypotenuse squared. Okay, so what is this answer here, people? Let's put it in a calculator. That is going to be 2 times 3 over 5 times negative 4 over 5 over negative 4 over 5 squared. They give you negative 3 over 2. Is that correct? Negative 3 over 2. Okay. Alright, let's carry on with our lives. Just let me know if there's something that you're confused about. It will benefit whoever's watching it later on. Also, the paper as well as the memo, the marking memo will be found in the description box below. Okay. So, looking at 1.2.1, we are given cos of x minus cos 2x plus 2 over sine 3 sine x minus sine 2x is equal to 1 plus cos x over sine x. People, which side is more complex? The left hand side or the right hand side? Left hand side. Not so as the question says prove the identity. So of course that one we can determine already at this point as that can only be it can only be one. So it's going to be 3 sine x minus 2 sine x cos x. You all agree with that? Which then gives us, in the denominator, sine x is a common factor. I'm then left with 3 minus 2 cos x. You all agree with that? But if you look at what we have on this side, it's only sine x. So of course, that needs to cancel. Not so. Now we go back here and we see, we're looking on top. Okay? We're looking on top. What do you notice here? We have cos x. Not so. So which one of the three is that going to change to? The one dealing with cos only. If this was sine x, then I would have dealt with the one dealing with sine x. Okay. If this were to be sine x cos x, then I would have said cos squared x minus sine squared x. You guys understand? So as I said, we're going to change it to the one dealing with cos only. So it's negative 2 cos squared x minus 1 plus 2. Get rid of the bracket. It then gives us a negative 2. I'm going to put the cos at the back. As I can see, I'm going to go into trinomial factorization there, as you can see.
Sorry, sir, we couldn't get out on this check, so we just switch it over to one package.
It's fine. Okay, so that is going to give you 2 cos squared x, that's plus. Then you got cos x. And then that's going to give you positive 1, not so plus 1 is going to give you 3. You all agree with that? Nope, there's a mistake. This must be negative here. That is why you're looking so confused. Is that correct? No? Now you got trinomial. So what we do is, in the place of cos x, I replace it with a y or x, whatever. So the trinomial now reads 3x minus 2x squared. So that's your trinomial. 3 minus 2 is 1. So it's 1 in x. So that is going to give you plus and minus. Okay? So if we now replace again x with cos x, it's going to be 3 minus 2 cos x, 1 plus cos x. And this is all over sin x into 3 minus 2 cos x. So what we notice now, people, what do you notice now? Just check this thing is recording here. So normally when we enjoy ourselves the most, and then this thing cuts out, then that cancels, not so. So what are we left with? 1 plus cos x over sin x. And we look at the right hand side, what we notice? It's exactly the same. So I call it the left hand side is equal to the right hand side. Okay, any confusion there, people? I'm going too much over there and behind the calculator, but it looks over. Okay, any confusion? Right. Then the next question say probably talk about your, yes, for which values of x is in the interval from 0 to, is a given identity undefined. People, when will the identity be undefined? When the, yes, you started off well. When the, yes, denominator, yes, equal to 0. The sum will be undefined when the denominator is equal to 0. Okay. So I'm going to take this off so that I can keep the question in focus. So if you look at the denominator, that is my denominator there, and that's my denominator. Also, when there's a tan of x, immediately it's going to become 90 plus k times 180. It's also undefined at the asymptotes. Not so? So, if you're going to look at 3 sine x minus sine 2x. Okay, but this we factorized already. That's why it's only 4 marks. What is it factorized into? Sine into 3 sine x cos x. Is that correct? What did it work out to be, people? 3 minus 2 cos x. Okay, but outside was sine x. Is where that is equal to 0. So in other words, is where sine of x is equal to 0, or where cos of x is equal to 3 over 2. Not so. Or we can say where 3 minus 2 cos x is equal to 0. Okay. Then we land off with cos of 3x. Cos of x is equal to 3 over 2. People, if I go off cos of 3 over 2, there's no solution there. It will give you an error. Why? Because if you look at the cos graph, that is 1 and minus 1. What do we notice? 3 over 2 is way higher than the graph itself. So it's outside that range. That is why you'll get no solution on that equation. Okay. Also, sine of x equal to 0 is also accounted for here. I'm not going to write it down twice. Does it make sense? So what we do is we now draw the sine graph. Remember that is 1 and minus 1, and that is 360, 180, 90 and so on. Where sine of x equal to 0 is equal to 0 at 0, 180 and 360. Not so. But remember, there's a restricted domain. It's only from 0 to 270. So what's the solution? Therefore x is equal to 0 degrees, or x is equal to 180 degrees. Why? Because they only wanted from 0 to 270. Otherwise, if it didn't give you a restriction on your domain there, Onela, nearly, black, girlfriend, don't talk to them now, please. You had them all weekend. I'm only seeing them for 50 minutes today. Okay? I feel like I'm being cheated on. Okay? So, if it was general solution, then I would have said x is equal to 0 plus k times 360, or x equal to 180 plus k times 360. Or the shorter version, which is x is equal to 0 plus k times 180. Why? Because that solution is picked up every 180 degrees from there. Okay. People, the next one, question 3, 1.3, sorry. We are given that cos 27 times, sin 27 cos 13 is equal to A, sin 13 cos 27 is B, cos 27 cos 13 is C, cos 27 sin 27 sin 13 is D. Express the following in terms of A, B, C and D. So looking at this here, the first question is cos of 40. Let's put this there. So number 1 is the cos of 40. So I must link the 40 to two of these angles in. Not so. So how do I can get 40? We know that 27 plus 13 is 40. Not so. So in other words, this is going to be written as cos 27 plus 13. It's going to give you, of course, cos 40. So this is now cos of alpha plus beta. So cos alpha becomes cos of 27, cos beta, cos 13, opposite sign, sin 27, sin 13. So now we go and see, okay, cos 27, cos 13 is C. Can you see that, people? Minus sin 27, sin 13 is D. So in other words, that's C minus D. Okay, that's very simple, no? You tell me, why are they having the maths question so easy for grade 12s? No, that should be your question. Alright, sin 14. People, are we going to get sin 14 out? Sin 14 is the same as sin 27 minus 13. Why am I going to 27 minus 13? Because of what is given to us. Okay? Because I also know that 15 minus 1 is also 14. And 7 times 2 is also 14. But because we got 27 and 13 here, that is why I'm using those variables. You guys understand? So we're going to go with the cosine expansion. So it's going to be sin alpha, cos beta, same sign, sin beta, cos alpha. So that's simply going to be sin 27, cos 13, so that gives us A, minus sin 27, cos 27, sin 13, cos 27, sin 13, or sin 13, cos 27 is the same thing, minus B. Okay, there we go. Alright, let's carry on. The next question. It says in 1.4 evaluate, or simplify, or calculate, it all means the same thing. Okay, so what do we notice? What must be done first here? LCM. Not so. What's my LCM here? Sin 2x, cos 2x. So that must be multiplied by what? Cos 2x. So it's going to be sin 6x, cos 2x, minus cos 6x, sin 2x. Let's say, okay. Looking at the top here, we got sin. Now you see, in place of 6x, I put the alpha and the beta. So that is going to be beta and alpha. So what does that remind us of? Sin alpha cos beta minus cos beta sin alpha. I just tell you now sin when you say cos. The ratios are different. So it's a sign. If the ratios were the same, like cos, cos, sin, sin, that is the cos rule. Does it make sense? Alright. So it's going to be the sine rule with a plus or minus between it. With a minus between it. So it's going to be sine alpha minus beta over. Now looking at sine 2x cos 2x. Now 2x I replace in my mind with alpha. Where have I seen sine alpha cos alpha? Sine 2 alphas. You see sine 2 alphas. It's almost right. Because that is going to be 2 sine alpha cos alpha. Not so. But what are we missing here? We're missing a 2 in front of that. Not so. So if I put a 2 here, then I should put a 2 on top as well. Why? Because that 2 cancels 2, give me 1 negative. You guys understand? So I'm going to keep that 2 there. Just going to draw this down here. I'm going to draw this down here. If I put the 2 here, there goes the 2 as well. Okay. So there goes a 2 in front of it. Okay. Otherwise, if what I could have done here was I could have said a half into 2 sine alpha cos alpha. In this case, it would have been 2x. It would have been just a half sine 2 times 2x. Can you see that, people? Otherwise, having that top on there is the same as multiplying it by a half. Okay? So 2 sine 2x cos 2x is simply going to be sine 2 times 2x. Okay. So what is 6x minus 2x? 4x. So it's going to be sine 2 sine 4x over. Looking here in this denominator, that's going to be also sine 4x. So what's going to happen? Cancel, leave you with 2. Okay, so the answer is 2. Alright. Any questions here? You got the question, but you're not sure about the question.
No.
Right. Can somebody just open the door, please, man? In the corridor? Somebody's knocking there. Don't you guys hear? No. Okay, I'm hearing things. Go open some. That might be wrong. The person might be gone by now. Now we are given this here. We are given cos of 330 plus cos x cos 330 plus sin x sin cos 120 is equal to 2x. Determine the general solution of the given equation. So what is the first thing? I know we guys we didn't do this yet, no? Thank you. We're going to reduce that to? What are we going to reduce that to? Yes, good stop. Acute angle. So that's going to be cos of x, cos of 360 minus 30 plus sine x, sine. So I'm going to try and pick up 30 if I can. Why would I want to pick up 30? So that I can have cos alpha, cos beta plus sine alpha, sine beta. Or cos alpha, cos beta minus sine alpha, sine beta. You guys understand why? Then I can use the cos compound angle. Can you see that? So that is simply going to be 90 plus 30 degrees. And that is equal to cos of 2x. So 360 minus takes us to which quadrant? 360 minus fourth quadrant. Is cos positive or negative? Cos is positive. Cos 30. Now 90 plus which quadrant? Second quadrant. Is sine positive or negative? Positive. What changes to? Cos. So it's going to be sine x times cos. No, I made a mistake now. No? I was supposed to have written cos 90 plus 30, which now becomes sine of 30. Okay, sorry about that. So what comes to mind, people? Cos alpha, cos beta plus sine alpha, sine beta? Cos compound angle. Not so. Opposite sign or same sign? opposite. So it's going to be x minus 30 is equal to cos of 2x. So what are we doing now? If that was the sum, then we, under normal information as we did before in grade 11, we should be able to calculate this. Okay? So that first two steps is grade 12 work. From here it goes back to grade 11. So that cancels. So I say reference x minus 30 is equal to 2x. So what question comes to mind? In which quadrant is cos positive? Yes. And in which quadrant is cos positive? First and fourth quadrant. How do we get into the first quadrant? It's quadrant 1. It's just going to be 2x is equal to x minus 30 plus k times 360. Why 360? Because the cycle on the cos graph is 360 degrees. Okay? Solve for x, so x is equal to minus 30 plus k times 360. Or you can have it as 330 plus k times 360. The same thing. No? Or, how do I get into this quadrant? Quadrant 4. So it will be 2x is equal to 360 minus x minus 30 plus k times 360. Or you could have just written it as 2x is equal to negative x into negative 30. Or negative x plus 30. But because we always work with positive angles and we have a positive outlook on life, no? We use positive quadrants. So we have 2x is equal to 360 minus x plus 30 plus k times 360. So it becomes 3x is equal to 390 plus k times 360. Divided by 3, so I get 130 plus k times 120. You can write it like that, or x is equal to 10 plus k times 120. It's the same thing. Okay, what's wrong, Michael? 110. Did I make a mistake? Yes? On this one, yeah. Right on top. Yeah. This one. This one. Yes, absolutely. Remember I had a sign here. You remember that? And I took that sign based on that. So this should have been actually negative here. So it's supposed to be plus here. Right, sorry about that, my mistake. So they must go plus. So why did you tell me earlier? What's wrong with you guys? You want me to first make a mistake? Yes, okay, nice. Alright, so here we go. X is equal to, of course, 30 plus k times 360, correct? Now we're right, no? And then 2x is equal to 360 minus x minus 30 plus k times 360. So that is then going to give us 3x is equal to 330 plus k times 360. So x is 110 plus k times 360 times 120. Now you don't want to even give me a chance to make a mistake. Right? People, is that now correct? Right, thank you. If I make a mistake, to stop me. Then I don't have to embarrass myself. How are you guys doing? People, it says hence, so I need a previous calculation. So we are told in 1.5.2, hence means to say from the solution of your previous question. Solve for x in the interval from 200, x is greater than or equal to 200 but less than or equal to 360. People, where do we start? We start with 0, where k is 0, not so. If k is 0, then x will be 30 degrees, not so. What did I forget to write here? K is an element of. What will happen if I have left that out? Let's lose one more. What if I write it in? No extra marks. Then you don't actually get a mark. But you lose it if you leave it out. It does to me. Okay. Because the reason for that is because imagine you just bring your variables in. The people that's by the pot, you won't know who they are. So you must introduce your x's, not so, and your variables. Because did the sum have a k in it? No. So we brought the k into the sum. So we must say what the k stands. You understand? Okay. People then solve for x in the interval. So if you start here, k is 0, I'm going to get 30. If k is 1, I'm going to get 390, which is outside. No? If I get k to be minus 1, it's going to give you negative 330, which is also below. Now we go on that side. If k is 1, what do we get? 110. Not so. If k is 2, I'm going to get 230 degrees. If k is 3, again outside. So that's 240 is 330. Yeah, it's actually in. 240, 350. And there we go. These are two solutions. Okay. Any confusion there? No? Let's carry on with our lives. Q1.6 for 6 marks. Show that cos of 15 is equal to the square root of 2 plus square root of 3 over 6 over 2, sorry. Alright, so where do we go? Left hand side, right hand side? Left hand side. People show that to approve that question. It's not needed to us. We work with one of the two sides. Okay. People, cos of 15 can be written as what? Cos of 45 minus 30 degrees. Normally say show that without the use of a calculator and so on. Okay. That is your cos expansion. So cos alpha minus beta can be written as cos alpha cos beta plus sine alpha sine beta. Okay. So that's going to become cos of 45 cos of 30 plus sine 45 sine 30. Cos 45 is 1 over root 2 times cos of 30 is root 3 over 2 plus sine 45. It's 1 over root 2 times sine 30. It's going to be a half. Okay. So as you can see here, we have the same denominator. So it can be written as 2 root 2 root 3 plus 1. Okay. But what you should note here is that your LCM, your denominator, sorry, there's only 2 in it. Not so. So I'm going to divide throughout by, I might be wrong, root 2. So 2 root 2, so that can be written as the square root of 3 plus 1 over the root of 2 divided by 2 root 2 over root 2. Why did I do that? So that the denominator can have a 2 here, which I do have here. Okay. And then root 3 divided by root 2 I can rationalize the denominator. Nope, there's not no. Yes? Root 2 over 2 is the same as 1 over root 2. That's the same. Root 3 plus 2. Must rationalize the denominator. pause the video before we run out the thing. Okay, so I just had to go one step further, as I made the error and I was a bit confused here. So as you can see, when you go put each one of its own, or I multiply this by the root 2 over root 2. Root 2 times root 2 is 2, and root 2 times root 3 is 6, and root 2 times 1 is root 2. So in simplified version, that's going to be root 6 plus root 2 over 4, which is this answer I'm getting here. Okay? So, of course, that is not equal to the left-hand side. So what you do is you take the left-hand side, sorry, the right-hand side. You take the right-hand side now. RHS is going to be, so this can be written as the root of 6 plus the root of 2 squared. I'm messing it up again. Okay. If I multiply this by root 2 over root 2, so that is going to give us the square root of 4 plus 2 root 3. Not 2, it will be 6 actually. Over 2 root 2. Okay? Let me just simplify that again first, before I mess up. Okay, I'm not going to waste any more time on this. I don't know how to go from there to there. Okay. There is a way, I know I've done it before. But there's just one step I'm missing up here. So, if I had gone this route and you come up to this point here, that would have given you already 5 out of 6. Okay. So, it just slipped my mind. How am I going to convert this to look exactly like that? Okay. So, I'm sure most of you have external help. Please find out and let me know, and then I can just add it to this video. Okay. But according to the memo, when I did it that time, I used actually the double angle. Okay, so it's 2 by 15. So what I'm going to do is I'm going to use the cos 2 alpha is equal to 2 cos squared alpha minus 1. But the alpha angle here is 15. So it's 2 times 15 equals 2 cos squared 15 minus 1. Okay. So now I'm going to make cos 15 the subject of the formula. Okay. But cos 30, I'm doing the 1 over becomes plus 1 divided by 2, the square root thereof. Remember that is squared, okay? Just keep that. So cos of 30 is root 3 over 2 plus 1 over 2 equals cos squared 15. Now I take the square root. Normally when I introduce square root, I must not forget plus minus. But because that is plus, I'm going to drop the minus, okay? So cos of 15 is equal to, so under the root, your LCM of course on top is 2. So that's going to give you the root of 3 plus 2 over 2. That's on top. Divided by 2, which is the same as multiplied by 1 over 2. Which is the square root of 3 plus 2 over 4. Now the square root of 4 is 2. So this can be written as the square root of 2 plus root 3 over 2. Again, sorry about that. If you guys get a solution to how we can convert that to root 6 plus root 2 over 2, you bring it back to me. Otherwise, if I got it before you, I will let you know. People, for the rest of the paper, we will do in our next lesson. Enjoy the rest of your day. Good afternoon, class.